Welcome students, you are welcome to another video lecture series of English 101 General Mathematics 1. We shall be treating study section 6 today titled Polynomials. After the end of this study section, you should be able to define polynomial function, state the remainders theorem, and perform simple operations on polynomial functions. First of all, what is a polynomial? Polynomial is an expression of more than two algebraic terms, especially the sum of several terms that contain different powers of variables. I said it is an algebraic term in the sense that it is separated by the signs minus and plus, and it contains several variables that have functions of power. Let us treat some examples on the addition and subtractions of polynomials. Example 1. If px1, that's polynomial function 1, is 6x cubed minus 4x squared plus 2x plus 3, and polynomial 2, 4x squared plus 3x plus 2, and polynomial 3, 5x squared plus 4x minus 5. Now, the first question is, we had polynomial 1, the function of x, and polynomial 2, the function of x. From the example which I've written here, we are to add polynomial function 1 and polynomial function 2 together, and you will see exactly as I've written polynomial function 1, 6x cubed minus 4x squared plus 2x plus 3, and polynomial function 2 is 4x squared plus 3x plus 2. I have added 0x squared to stand as the function that is going to add the upper one together, and from here now we are to add it together. 3 plus 2, don't forget the plus my sign here. 3 plus 2, that is 5, plus 2x plus 3x, that is 5x, then 4x squared minus 4x squared plus 4x, that will be 0. And 6x squared plus 0x cubed, 6x cubed plus 0x cubed equals 6x cubed. I think you got this now as I've explained. 3 plus 2 equals 5, 2x plus 3x equals 5x, minus 4x squared plus 4x squared equals 0x squared, and 6x cubed plus 0x cubed equals 6x cubed. Now, we shall be treating another example again. Let's just go to example 2. Now, we have to add polynomial function, we have to subtract polynomial function 3 from polynomial function 1. And that is exactly what is written on the board now. Now, as it is written on the board, we will subtract polynomial function 3 from polynomial function 1. Don't forget, I have also written here 0x squared that will serve as the variable that will be subtracted from x squared, because it is not written in the original polynomial function. Now, here we start plus 3 minus plus 5. It becomes plus 3 minus 5. That means we have minus 2, right? Now, plus 2x minus 4x. It becomes plus 2x plus 4x, that is plus 6x, and here minus 4x squared minus plus 0x squared becomes minus 4x squared minus 0x squared, that is minus 4x squared. Now 6x squared minus 5x cubed, 6x cubed minus 5x cubed, that is s cubed. I think you understand it the way I've done it here. Now, that is exactly what we have done. We shall be going to remainders theorem. Now, we shall be going to remainders theorem now. The remainders theorem is useful for evaluating polynomials at a given value of x. The theorem talks about dividing polynomial by some linear function or factor x minus a, where a is just some number. The remainder theorem starts with an unnamed polynomial px, and there is a variable x there, which is used to evaluate the remaining factor after which it has been divided by the linear factor. Now, just as I've written on the board here, this is the polynomial function s cubed plus 2s squared minus 4x plus 3 is a polynomial function, and this is a linear function x plus 1, where x is a variable and 1 is a real number. Now, if we are to divide this polynomial function px equals s cubed plus 2s squared minus 4x plus 3 by x plus 1, at the end of the day we get factors remaining qx, which is the quotient, and the remainder, which is the x. This qx will be the quotient, which will be the remaining factors when this polynomial function is divided by the linear function, and the rx is the remaining number. Now, just as it is written on the board, you draw the division line like this. You write the polynomial function in there, and you write the linear function outside. Now, we start evaluating it by first dividing the first variable here, s cubed, by the first variable x, which is outside. Now, you get s cubed divided by x, you get s squared. Now, you multiply s squared by x, you get s cubed. Are you following me? Now, you multiply the real number 1 by s squared, which is written up here. Now you get s squared multiplied by 1, and you get plus x squared. Now you subtract what you have got from this one that is written up here. S cubed minus s cubed will give you 0. Now 2s squared minus s squared will give you s squared. Now you bring the remaining one up here down, minus 4x plus 3. Now you start your division again with your divisor, with what is written here. Now s squared divided by the first variable here again, x, will give you plus x. That's s squared divided by x will give you x. Now you multiply again, x by x will give you x squared. You write it here. Now x multiplied by the real number here, 1, will give you plus x. That's x times 1. Now you subtract again, don't forget. S squared minus s squared will give you 0. Then minus 4x minus x will give you minus 5x. Now you bring this 3 down again. Now you start your division again. Minus 5x divided by x, which is the variable here again, will give you minus 5. Don't forget. And then you multiply minus 5 and 1 will give you minus 5 times x will give you minus. Now, like I said earlier, minus 5 times x will give you minus. Now we give you minus 5x, then minus 5 times 1 will give you minus 5. Then you subtract again, then this will give you 0. Then minus 3 minus minus 5 will give you 8. Now, like I said, your quotient function will be that one which is written up here, s squared plus x minus 5. Now, and the remainder function is 8. Now, that is it. Now, another way of solving the example we just finished now is by equating the linear function or the divisor to 0, and you make your x, which is a variable, the subject of formula. Now in this case, x plus 1 equals 0, x equal to minus 1 when you take this one to the other side. Now you insert the minus 1 into the polynomial function. Wherever you see x, you put minus 1. In this case, s cubed plus 2s squared minus 4x plus 3. Now you put minus 1 cubed plus 2 into bracket minus 1 squared minus 4 into bracket minus 1 plus 3. Minus 1 raised to power 3 equal to minus 1. You understand that? Minus 1 times minus 1 times minus 1. Then minus 1 squared equals to 1 times 2, that is plus 2. Then minus 1 times minus 4 plus 4, then plus 3. When you sum the whole thing together, it gives you 8. I think this is the simplest form of solving that example. Now let us go to another example. Now in this example, you have to find the remainder when s cubed plus 2s squared minus 4x plus 3 is divided by x plus 3. This is the polynomial function, and that is the linear function. Now, like we did the other time, you draw the division line, you insert the polynomial function in it, and you put the linear function outside. Now 2s cubed divided by x will give you 2s squared. If you multiply that together, you get 2s cubed, and then 2x squared times plus 3 will give you plus 6s. You draw the line and you subtract. Don't forget, this one will give you 0. 2s cubed minus 2s cubed 0. Then minus 4s squared minus 6s squared will give you minus 10s squared. Then you bring down plus x and minus 3. Then you divide again. 10s squared minus 10s squared divided by s will give you minus 10x. You multiply again, it will give you minus 10s squared. Then times 3 will give you minus 30x. You draw the line, you subtract. Minus 10x minus minus 10x will give you 0. Then plus x minus minus 30x will give you plus 31x. Then you bring the 3 down. Then you divide again. Minus 31x by x will give you 31. If you multiply, it will give you 31x. Then 31 times 3 will give you plus 93. Then you draw the line, subtract again. Then minus 3 minus plus 93 will give you minus 96. Then the quotient function here is 2s squared minus 10x plus 3, and the remainder function is minus 96. Now in the next slide, it is just the other way of solving it, where you have to equate the linear function to 0, define the equivalent of x, and then you insert it into the function and you get it. Now, thanks for listening.